Good morning. Welcome to my talk on graph databases and Apache TinkerPop. So before starting, who is familiar with graph technologies here? Please raise your hand, okay. Who is familiar with Apache TinkerPop or Gremlin? Some of you. And with Neo4j and Cypher? Okay. So first, let me introduce myself. My name is DuyHai DOAN. I'm working as a technical advocate for Apache Cassandra at DataStax. Who knows Apache Cassandra here? Okay. I'm also a committer for Apache Zeppelin. Who knows Zeppelin? Few of you, okay. Zeppelin is just a notebook for your big data project. And I am also the maintainer of the Zeppelin Cassandra interpreter. So I'm working for DataStax, which is a company offering DataStax Enterprise, a commercial distribution of the Apache Cassandra open source project. So we add some extra feature to the open source project. But the topic of my talk today is about graphs, right? Graph databases. So first, let me show you some use cases of graph databases. The first use case is recommendation, right? When you have an online website, you are selling products. So you want to identify the relationship between the customer and what they have purchased as products, and every product they have purchased, how many stars or what is the rating they gave to those products. And then with all those data, you try to find the best product to recommend them, right? So typically, this is this kind of use case. On a web page, you have on the bottom some recommendations. With graph, it is very easy to do that. We'll see a demo later. The second use case is social network, right? For example, you are on Facebook, on Twitter, and you want to find all the users that share the same interests as you, right? Or you want to find some users in your network based on some filter. So we can use graph, because every users are connected some way, right? So you can start from the main user, which is Steven here, and try to expand the graph to find matching users. Another example is for medicine. So for example, when you have some disease and you want to find correlation between different diseases, so you build a map. For example, you can see that there's some correlation between diabetes and obesity, right? So when you build a graph of those diseases, you can find correlations. And the last use case for me is when you are managing IT infrastructure. For example, you have connected devices in your infrastructure, and you want to know if, for example, here is a power network. So if some equipment goes offline, what are the influences on the other equipment? Do I have a power shortage here on the right and some power shortage on the left, and so on? So you can model those equipment as nodes in a graph and try to understand, analyze the impact of each equipment going offline. Everyone here in the room probably knows already about relational databases, right? So I want to do some comparison between graph and relational database. So with a normal RDBMS system, you have this kind of schema. You have a user table, a movies table, and a view table. So this person has watched this movie at this time. So it is a joint table, right? And in fact, with relational database, you first define the relationship between entities, and then you can store those entities and relationships in a normalized fashion. With graph databases, you can do the same thing, right? Here, you have a user vertex, a movie vertex, and a connection between the user and the movie with an edge view. So with a graph database, you can do the same thing, define the relationships, store the entities and relationships. You can also allow the user to explore all the relationships and also to discover unexpected relation. So, for example, you are doing some query and you discover some unexpected connections between those vertices. I will show it in an example with my demo later. So in fact, the reason to use a graph database is when you have more value in the relationships than in the raw data themselves, right? Because you can always store your big data in a NoSQL database. But if the value of your business is in the relationships, then graph databases can help you. Any questions so far? No? Now let me introduce you to Apache TinkerPop. So what is this Apache TinkerPop project? It is an open source graph computing framework, right? So computing means it's not a database. You install TinkerPop on top of a data store. And with TinkerPop, you can navigate and compute all your graph data. It has been started in 2009, and since 2 years ago, it had joined the Apache Foundation. So now it is a top-level project. And with TinkerPop, you may see those cartoons. So each of the cartoons here represent a component of this framework. In fact, this framework is a stack, right? Rexter, the dog, the yellow dog here, is just the Gremlin server. So it's a web server. You have the Gremlin, the green cartoon, which represents the query language. And then you have many components, the core API, the user DSL, some provider strategy. What is interesting with TinkerPop is you can plug in many data stores. You can use Cassandra, you can use, I think, BarleyDB, and so on. So you are not restricted to a single data store to use TinkerPop. And in fact, you have two processing engines. The OLTP, which is the real-time, and the OLAP, which is the batch processing engine. So what does it mean? Well, when you do a query starting from a single vertex and try to expand, it is a real-time query. Why? Because you do not want to scan all your database, right? If you do some query which require a global ordering or a global group by, it means that you need to scan all your database. And in this case, this is a batch query. Some words about the graph database family. You have two kinds of graph database. RDF, which is based on a resource description format, and property graph. So my talk will be focused on property graph. So here you have some vendors which support Gremlin. So Neo4j, Titan, DataStax Enterprise, which is a graph database built on top of Cassandra, OrientDB, and so on. So what is a property graph? So this is the formal definition. A property graph is composed of vertices, or nodes, and edges, which are the arcs. Yeah, right? You have a vertex. You have a connection, so an edge, which is directed. So it has one direction between two vertices. You can have a connection between a vertex and itself. It is binary because you cannot connect more than two vertices with a single edge, right? And you have attributes. So you can have attributes on the vertex itself. So for example, for the user vertex, you have name, age, and You can have also attributes on the link on the edge. So on the view edge, you have view time, which is an attribute, right? Some definition. So this is the topology. A vertex and edge is just the topology. But how can I distinguish a user and a movie? Thanks to vertex label. Right? User is a vertex label. Movie is another vertex label. You can understand it as a kind of vertex, a type of vertex. Right? You have also edge label. You have a view edge label. You have a nose edge label. Right? Any questions so far? Clear? Let's move on. So now let's focus on the query language. How can I read my graph data? So to query my graph data, I'm using Gremlin. I need to define some words, some vocabulary. The graph, well, the graph is your data, right? Which is sitting on disk. The traverser, the Gremlin cartoon here, represents a thread, a CPU. At each time, your CPU is reading some piece of data. And what we call the traversal, this is the program. This is like the SQL query or the instruction to read the data. So this is an example. Here is my graph schema. I have a user with ID and name, which knows all the user. I have a movie with some properties, the title of the movie, the year of the movie. I have a person, which also have some properties, name and gender. And now the movie is connected to the person by two edges, actor and director. It means that a person can be an actor in a movie, or can be a director in a movie, or can be both actor and director. A user can give a rating to a movie with a value, which is rated here. Right? And so my question is, with this schema, give me all movies in which Harrison Ford has played as actor. So how can I answer to this query? So first, g.v. G is my graph, my whole graph, so my whole data. .v is give me all the vertices. So g.v means I will fetch user vertices, movie vertices, and person vertices. But I don't want all of those vertices. I only want Harrison Ford. So next, I said g.v has label person. I want only the vertices with the label person. Right. Okay. And then I want only the person whose name is Harrison Ford. So I add an extra filtering clause, has name Harrison Ford. So right now, I have a single vertex of type person, of label person. So there is a filtering on the vertex property, which is the name, right? Okay. Now, I said, give me all, I have found my Harrison Ford person. I want to fetch all the movies in which Harrison Ford has played as an actor. So it is very simple. I traverse from person to movie using the edge actor. So the step here, in means incoming edge. I want to navigate from person to movie using the incoming edge. And as you can see, there is an arrow, there is a direction. Right? From person, the incoming edge is actor. So now I am at the movies vertices. So this is the answer, the query to answer my question. Give me all movies in which Harrison Ford has played as an actor. So it is very visual. You see what's happening on the graph. Now, if I want to do something a little bit more complicated, give me all movies in which Harrison Ford has played as actor with the mean rating greater than 7. So the beginning is exactly the same as before, right? G.V has labeled person, has named Harrison Ford in actor. And now I add an extra step where, so there is a filter. Where what? Where in E rated, incoming edge rated, values rating. So I look at the incoming edge name rated. I look at the value rating. Mean is I compute the average, and I said that this average should be greater than 7. Right? So it is equivalent to a filtering. Now let me show you some more extended examples. Before moving forward with the demo, do you have any question? No? Clear? Fine. Let's move on. Yes?
Does it mean that this solution is a kind of virtual representation of our database, for example, Cassandra, another kind of NoSQL or SQL database? Is it created virtually in the memory?
So your question is how those graphs are mapped to the data store, right? So it depends on your data store. For example, with Titan, you can use Berkeley DB, Oracle. So I believe that the graph data are flattened out in tables. In Cassandra, in DataStax Enterprise Graph, each of the vertex is a partition in Cassandra, and the edges are the clustering columns. So it depends on the data source. So for each data store, you have a mapping between your graph schema and the schema of your own data store. So yeah.
Does it mean that we need to first install the database and on top of this we create such solution, or do we have an existing database and we can just put this solution onto this?
So the question is, does it mean that we need to install a database first and then put TinkerPop on top of it, or does it exist, a solution when you can just use it?
I mean, is it a kind of perspective, a view on my data in existing database?
Okay. So no, the answer is no. You need to create a data model for those graph data. You cannot just, oh, I have an existing MySQL database or Cassandra database or whatever, and just connect. No, because the data modeling is specific. So you cannot just reuse existing data. You need to transform your existing data to match the format of the graph. Right.
Are there any existing tools to do this effectively?
There are migration tools that can just read from using GDBC. We have what we call DataStax graph loader. We can read data from a GDBC connection. So if you have data already in Oracle or relational database, we can read from CSV and then import into the graph format. But there is no magic that automatically convert your data. You need to specify how you want to import. Yeah. Other question? No, so let's move to the demo. Okay, so the first demo is SQL to graph. I want to do this demo first because everyone in this room, who doesn't know SQL in this room, please raise your hand. Okay, I'm happy. No one raised his hand. So everyone knows SQL. So I want to start from an easy point, right? Everyone knows SQL. So how can I move from SQL to graph query? So let me show you the schema. So it's like before. I have a movie connected to a person with two edges, director and actor. A person can be a director or an actor or both of a movie. A movie belongs to a genre, like a science fiction, action, drama. A movie is rated by some users, which knows all the users, like on a social network, right? Okay. So the first thing I want to show you is the G.V. What is the type of G.V? It's like it looks like magic. So in this console, this is groovy. The query language is just groovy, right? A groovy console. So this is a default graph traversal. So if we look at the API, a traversal is just an iterator of something, like a stream of data. So of what? In fact, it is an iterator of vertex, right? So here, I want to do select star from movie limit 10. So give me all the movies, limit 10. My Gremlin query will be g.v. So g.v is an iterator of vertex, of course. Has labeled movies. Now, you say that you want only the vertex of labeled movie. So it is equivalent to doing a filter x instance of movie. Suppose that you have a movie Java bin, right? Limit 10, movies tag 10. Just execute it. OK, this is my first 10 movies. OK, fine. Now, if I want to select a single column, select title from movie. The beginning is the same. G.v has labeled movie. Now I said dot values title. Give me the title property of my movie. So it is equivalent to transforming an iterator of movie into an iterator of string. So you are using the map, like in Java 8 stream. You are using the map operator. From the movie, I extract the title. So now I have an iterator of string. I get the first 10 title. OK, simple. If I want to select multiple properties, multiple columns of my movies, select country, duration, title, year, I will use the value map. So as its names imply, it is a map of value. So from my iterator of movie, now I have an iterator of what? Of map, of string object. The key of the map is the label, the property, right? Country, duration, and the value of the map, well, is the actual value. So let's see. If I display the row, see, you have a list, a sequence of maps, so key value, key value, key value, key value. OK. Now let's do something more complicated. What if I add some filtering, where clause, right? Select star from movie where year equals 2000. Give me all the movies released in 2000. Has label movie. Now I add an extra filtering, has year 2000. It is equivalent to do a filter step on your iterator. Just that. So maybe I want to put a limit because I may have a lot of movies, so limit 10, for example. So here, release year is all 2000, right? Now, if I have multiple clauses, multiple filtering, where year between 2000 and 2010 and country is France, well, I just change the has step. I have multiple has step. Pretty simple, right? Year, country. OK. What's about ordering? I want to order all the movies by their duration and by descending order and only take the top 10. So now I have a step which is called order. Order by what? By the duration property of my movie in descending order. And then I call value map title duration. See? Order by descending duration. Simple. It is equivalent to a sorting in Java 8 stream, right? Now, oh, group by. Interesting. So I want a select country max duration as longest duration. So in fact, I want to, for each country, give me the biggest duration of the movies released in this country. So g.v has label movie. I have an iterator of movie. Group by what? So I have two by here, which is really strange. So the first by clause is the grouping, right? So from an iterator of movie, now with the first by clause, you have an iterator of map, string, collection, movie. The key of the map is the country, because you group by country. The value is a list of movies belonging to this country. Fine. What is the second by step? In fact, you are doing a projection here. You say, instead of having a collection of movies, I want to take the values duration for each of the movies in this collection, and I take the max. So now, I have an iterator of map. The key is always the country, but the value now is a single value, which is the max duration. You can always, with Gremlin query, you can always, because it is an iterator, you can always call next, and then get class. Give me the first element of my stream, and tell me what is the class, hash map, right? Or next, just display a single hash map, key value, right? And you can also use the count. Count is how many elements do I have in my iterator? 1. Okay, so it is an iterator with a single map inside. And the map contains all the grouping, right? So now I want to order. So, okay, I have done my grouping, but I have order by max duration, descending. So I can do order by value. Value means the values of my map, which is the max duration. I can also order by keys, which is the country, but I'm not interested by the keys, by value. If I do that, well, it's not working, see? It's not ordered correctly. Why? What is the reason? The reason is if you do an order like this, you are ordering all the elements in the iterator itself. How many elements do I have in my iterator? 1. So it doesn't make sense. Because there's just one map. So you order by just one map, so it is the map itself. Now if I add the local keyword, it means that take the iterator for each collection in my iterator, order this collection locally. So now, with order local, it works, see? So I want to order inside the map in my iterator. And the same for limit. You say limit local. And now I have the top 10 value. Okay? Soviet Union, wow. It still does exist. Inner join, wow. Let's do something complicated. What is the equivalent of a SQL join in graph? It just travels, so just moving from a vertex to another one. I want a movie title and the genre name from movie. So there is a big inner join here between the movie genre table and the genre table and the movie table. So I want to fetch all the movies with genre equals to sci-fi. Right? Science fiction movies. The beginning is the same, has label movie, g.v has label movie. Now I want to filter. I do not want to fetch all the movies, only the one which, let me show you the schema again. It is important to have a schema here. At this stage, I am at movie, right? I filter my movie by outgoing using the h belongs to. So from here, I'm going here. So now I am at the genre. And the genre has name sci-fi. So I should only take the movies whose genre is sci-fi. And then I do a projection. Projection, what is a projection? So it is equivalent to do a select. I want to display some columns. But why do I need the project operator and why don't I use the value map like before? The problem with value map is, with value map, you can only fetch the properties of a vertex. The genre of a movie is not a property. The movie has those properties: country, duration, movie's ID, production, blah, blah, blah. But the movie genre is not a property, it is another vertex. So to display the movie and its genre, I need to do a projection with some traversal. So project by title label. So the parameter of project is just a label. Just a label. So project by title, which is the property of the movie, and by what? By outgoing edge belongs to values name. So give me also all the genres of my movie. This special operator is because one movie can have multiple genres. Right? It can be a science fiction movie, it can be an action movie. So I am doing just a fold step to concatenate all the genres in a single string. Limit 10. So here we are. Alien Resurrection is a science fiction and horror movie. Total Recall is a science fiction and action movie, and so on. Right? And in fact, the join here, you can see here with SQL, is transformed into just a traversal in Gremlin. It is just a filter step, and then you move from one vertex to another one. As simple as this. Any question so far for this demo? No?
I have a question about, but it's probably about implementation in like a data source. And I understand it may differ between like
Wait. Yeah, repeat your question for the audience.
Can you hear me?
No.
That's it. No. Okay. So I have a question about traversal. Can you go one page up? So you have this has label here, and I understand that it may like GD has label mode.
Yeah.
And I understand it may be different between databases, like data sources, like it's probably different in Orient DB or something like that. But how it's in general implemented usually in various graph databases. So because it seems to me like for every query in graph database you need to iterate over all over every vertex in your database, and it does not seem very efficient.
Okay, so excellent question. So I do a summary of your question. So the question is, okay, G.V has label. We understand that we only want to fetch the vertices of movie label. But how is it implemented? Does it mean a full table scan? Again, the answer is it depends on the vendor. For example, I can talk about DataStax Enterprise Graph because it's, I know how it is implemented. We implement it as a clustering column in Cassandra. So it's a kind of primary key of my Cassandra table. So it is a direct access. But in OrionDB or Neo4j or whatever the data store, they can choose to implement this by using indexes, by using also primary key. So it all depends on the vendor implementation. Right? There is no, in fact, you need to understand that TinkerPop and Gremlin is just the framework. It defines the contract. Right? If I have a hash label step, I need to filter all my vertices to keep only those who has this label. But implementation, you can use whatever you want. Think about, it's like an ETL engine, right? And the implementation depends on the vendor. So of course, the hash label step is very used. If you can see, all of my example use the hash label. So in fact, most of the vendors either implement it as a primary key, a part of the primary key, or an index. Nobody will do a full table scan just to filter by label. Other question? Okay, let's move on. Complex example. Advanced. So let's see a recommendation engine. How can I do a recommendation engine with graph? Most rated movies of Harrison Ford. Okay. G.V.has person name. This is a shortcut to has label person has name Harrison Ford. So at this step, I have an iterator of person with a single element, which is Harrison Ford. Okay. In actor, so give me all the movies in which Harrison Ford has played as an actor. Fine. So I have an iterator of multiple movies. Order by what? Aha. Let's look at our schema. Order by in edge rated, here. Values rating, the rating value. Compute the average. And order by descending order. So now, if I stop here, I will fetch all Harrison Ford movies and order them by their average rating. Right? But with the display, I don't see the average rating. So I need to do a projection again, project by movie title and by average rating. So now, okay, here we are. Surprisingly, or maybe not, Blade Runner has a better average than all the Star Wars movies. Is there any Star Wars fan here? Okay. Sorry, Blade Runner is better. So, hey, look at the rating. So, okay. So the most rated movie of Harrison Ford is Blade Runner. Fine. Give me all the genres of Blade Runner. So the beginning is the same, right? Limit 1 allow me to fetch Blade Runner. And now I have Blade Runner. I want to know the genre of Blade Runner. Well, I just navigate from Blade Runner to the outgoing edge belongs to and take the value name. So the property name of this vertex name here. Okay? So we have normally two genres, science fiction and action. Okay, Blade Runner is a science fiction and action movie. Right. Now let's do a recommendation engine. So imagine that you are on Netflix or whatever, you watch Blade Runner, you think, oh, this movie is great. I give a good rating. And now the website wants to recommend you some similar movies. So how does it work? G.V. has movie title Blade Runner. So I want to look for the movie whose title is Blade Runner. To answer your question or maybe possible question, I have an index on the movie title to avoid a full double scan. Again, it makes sense, right? Has movie title Blade Runner. So give me Blade Runner. And I save it as Blade Runner. So I give it a tag. Okay. Now I type in edge. So from the Blade Runner movie, I'm here. I'm going to the incoming edge rated. And I only take the incoming edge where the rating value is greater than 8.2, right? The average rating for Blade Runner. And then out V. So I'm going out to the user vertex. This step means give me all the people who have rated Blade Runner more than 8.2. From Blade Runner, I fetch all the users which has rated Blade Runner more than 8.2. Okay, so I have some users. So I'm here. At the end of this step, I'm here. I'm at the user vertex. I'm going back. So now from the user, I'm going out edge rated. So I'm here. Where value rating is greater than 8.2, incoming vertex movie. So this second step means from those users who rated Blade Runner more than 8.2, give me all the movies they rated more than 8.2. You see the pattern now? And all those movies which are not equal to Blade Runner, of course. I want to exclude Blade Runner from this set. Then I do some deduplication, and I project. I display the movie title, the average rating, and the genre. So let's see the result. Okay, I have a lot of results, 257. So those are the movies we may want to recommend. But if you look at the average rating, they are not that good, right? Some movies have an average rating of 6.6 and so on. Even 6.7 and so on. So, and I have too many movies. So I want to restrict this result. How? I say, I want that the movies I have found, their average value is greater than 8.2. Because those people who rated those movies more than 8.2, it is a single vote, but maybe other people rated it 1 or 2. So the average value may be lower. So now I add an extra filtering. Let's see. Okay. So now I have less movies. I have 36. 36 movies. And all of their average rating are greater than 8.2. But still, if you look at the genre of the movie, I'm not going to recommend The Godfather to someone who likes Blade Runner, even if the rating is super good, right? Because it's not the same kind of movie. Because it's a drama movie, and Blade Runner is a science fiction. So, what can I do? Again, extra filtering, where all the movies I have found, their genre should be within action or science fiction. And now I have only 3 movies, matching movies. 7 Samurai, action, good rating. Pulp Fiction, trailer action, good rating. And A Clockwork Orange, which is a science fiction and drama. See? So with a query in Gremlin, you can create a recommendation engine. Okay, of course, it is very simple. It's not as complex as all the collaborative filtering where you can add extra properties. But still, for basic recommendation engine, it just works. And the number of results you find depends on how much you filter. The more you filter, the less you have results, of course. And it can be done in real time. It is not a lab query because you start from a single movie, right? The user on your website, they clicks on Blade Runner. So you start from the Blade Runner, you try to expand, but you limit your expansion with filtering. Because every time I put a filtering step to avoid fetching all my database, right? Yes, question?
How can I access to this syntax? If I'm a C# developer or PHP developer, are there drivers or API available?
Can you hear me? Yes. If I'm a C# developer or PHP developer, how can I access to this syntax of query, the graph? Are there any drivers or API available if I create such a stack of technology?
Okay, so this syntax, we have drivers. So there are 2 ways. The first way is just to build your own string. G.v is just a string. You build your own string on your driver and just send them. But it is not the best way because it's error prone, right? You can make mistakes. The second way is to have a query builder. So we have a driver in Java where we have our own query builder, g.v, and then you put some filtering or criteria. And this
Only in Java?
yeah, we have. So we start first because it is a very new product for us. So we start first with the Java driver, and then we will extend to C#, to Node.js, to whatever. Other question? No, so let's move. Oh, question, please.
Can you like create more generic queries, like use that as Blade Runner in next queries? Like you can just get Blade Runner genre and use it like within action and sci-fi?
I don't get your question.
For example, can you create more generic queries? Because right now you create movie title Blade Runner and use action and sci-fi. And for example,
Okay. Yes. The answer is yes. Because here, you see the values are hard-coded. And you don't want this. Like, as a good developer, no hard-coding in my code. Always use variable, right? So yes, in Gremlin, we have the notion of traverser-induced variable. So when you traverse, you can save those values as a label right here, and then reuse them. Yes, we can do that. Why didn't I use it? Because it's already complicated, and I didn't want to add some more extra complexity in my query, because it's already complicated to explain to people this query. But yes, you can do.
thank you.
I would like to ask you about the documentation. Have you created a big, I don't know, set of how to use something like that?
Yes, sir. Gremlin. Oh, no. Sorry, yeah. No, not this one, yeah. So here, I zoom in. Let me zoom in. Oh, can I zoom in? Yeah? That's okay. So, ooh, no, not too much. Yeah, is it okay, right? So you have general step and step, and you have a lot of example by step, you see? So yeah, just on the main page of TinkerPop 3 documentation, you have a lot of example here.
What is the license?
Oh, Gremlin is open source.
Okay.
The framework itself is open source. The implementation, the data store, depends on, you can use Titan, you can use DataStax Enterprise Graph, you can use Neo4j or RDB.
Depends on vendor, okay.
Yeah.
Thank you.
But with Gremlin, you have also an in-memory implementation. Right?
I once tried to use Gremlin. I was interested at one point at OrientDB because it's actually multi-database and multi-model database, so you have possibility to access both SQL and other ways.
Yeah.
And because Gremlin, I remember that also gives you ability to add some data to. I might be mistaken, but to add some vertices into the graph.
Yeah, you have what we call mutating traversal. So during your traversal, you say, oh, I want to add some extra data. Yes, you can do that.
And would I break the OrientDB other relations like by using Gremlin?
I am not a specialist of OrientDB, so I cannot answer your question.
Okay.
So,
and in DataStax, you can only use one. I cannot access this data in any other way, like SQL.
You can always access to the row table in Cassandra using the Cassandra query language, SQL, but it is formatted in a special way. So yeah, but you can always see the values.
Okay, and Gremlin won't like operating. Like for example, if I change something in SQL mode, I won't break the.
You will break. So it is not recommended to hack the raw data in Cassandra. If you have a graph, data, you should mutate your graph using Gremlin, because when you mutate the graph using Gremlin, we perform consistency checks. So we are checking some properties that you are not breaking some, you are not deleting some vertices without deleting the edges and so on. So
Okay.
we do all of those checks.
Thanks, that answered the question.
Okay, so let's move on. Last example, because we may run out of time. No, we have 10 minutes left, right? So, oh yes, social network. Now let's focus on this user which knows other users. Typically, it is a social network schema. On Facebook, you knows other person which knows other persons. Okay. So, display the first degree relation of the user with the most connections. So g.v.has label, user, order by, outgoing edge, knows, count, decrementing, right? So this is a OLAP. This is a batch query. Why? Because I do full scan of my table. I'm doing a global order. So this is a batch query. So my data set is small, so I said graph allow scan is true. But in fact, in a real production, I should not do that. But just for the sake of the demo, right? So this guy, user 861, is the person who has the most first-degree relations. Okay. Find all people between 25 and 30 years old connected to user U861 by some degree. Aha. So has label has user ID. The person we have found, emit. Emit means now every time I found some user, I just emit it to the result. Repeat. This is the power of Gremlin. You can do loops, right? Repeat what? I want to navigate through the outgoing edge nodes. This one. Simple pass. Why simple pass? To avoid cyclic loops, right? And time limit. Because with this, you can expand infinitely. So I said my loops is time limit to 40 milliseconds. And then whenever I find some person, I said this person should have an age between 25 and 30. Okay, wow. So this is our user, right? The original users, and all the user he knows, and the path to reach them. Not only you have the result, but you also have the path to reach those target people. So this user is 26, and how to go from this, the original user, to this user, you need to go through another user. So the idea is, I want to find some people who share some common properties or common interests. For example, I want to find all the users who love science fiction movies. And once you find them, you say, oh, this guy knows this guy. So maybe we need to organize a party at home with science fiction movies, something like this, right? So this is my query. Find all people between 25 and 30 connected to my original user by some degree that like science fiction. What does it mean, like science fiction? It means that they have rated more than 8 science fiction movies. Question?
Can you create dynamically properties? Adding new properties to the vertex?
The question is, can we add new properties dynamically to the vertex? So no, in the schema, because Gremlin is a schema-full graph, so you need to define the schema first. And then dynamically, you can change or modify the value of the properties. But if the properties is not defined in the schema, you cannot dynamically add. So how to query this? So the beginning is the same, but now I have an extra filtering. So has age between 25 and 30, and filters outgoing edge rated, filter value rating greater than 8.0, incoming vertex, which is the movie, outgoing edge belongs to, so now I'm moving from movie So incoming edge, movie, moving to the jar, and should have the science fiction name. So now I should have less people. Okay, you see, I have reduced my data set. So all those people are connected to these original people, and they like science fiction movie. If I want to show the connection, I say pass, show me the path to go through this user to the target user. See? And that's it. So with graph, you can expand a social network graph with some criteria. And that's it. Do you have any extra question before closing?